All right, so yesterday we talked about the input, and like I said, at the end of the class, Brandon was actually asking the question. He was a little confused on this notation. There should be no confusion. We're talking about this being as y2, this being as y1, this being your x value of x2, this being your x1. So look at when we take this into consideration and we're looking here, all it is just a different notation. We're taking the 2 as our x, all right, and the 0 as our y value output. We're taking the 1 as our x and the 3 as our y. I'm just showing you the formula right here as f of 2 minus f of 1 over 2 minus 1. I'm just showing you a little bit of the formula. It's no different than a slope formula. We are just now using, though, function notality. We're function notation. So we're looking at these as just function notation. All right. So when we were talking about this down here, we were talking about what happens when we get to this slope and it becomes undefined. You know, what would be a reasonable guess? And we took a look because really, where does the point of when Q gets awful close to the point, let's say, uh, 1, 3. And where does that occur? Well, 1 is in between 1.1 and 0.9, and 2.79 is in between, and 3 is in between 2.79 and 3.19. So we're looking at this possible, it's somewhere in between there, and what's the number that we would try or think about that it would be in there? Well, we're saying that it's 2, negative 2. That's going to be our guess. And like I said, we're kind of taking this line and we're really trying to get as close to a tangent line as we can. We're taking a secant line, this point to this point to this point to this point, and we're trying to get as close to just touching that graph one time, which is what we call a tangent line. All right. So as we talked about at the very beginning of class, we said a tangent line exists, it's a line if it exists that touches a graph of f of x at a point P and runs in the same direction of the graph. Notice that this graph is curving down, so this tangent line is actually curving down as well. All right, so based on the example that we had, all right, or based on what we just previously did, remember that based on the previous example, we made an educated guess of that slope. So we are saying that the tangent line of that slope is going to be negative 2. So what's the equation? How do we solve that? Well, again, we're plugging in our points. Remember, our slope now is 2, all right, or negative 2. And our point that we're going through, or at this one single point, we're going through that point. Remember, that point is going to be that 1, 3. It's what we had a couple pages ago. So when we talk about it, we're going through the point of 1, 3. And this is where you can set up your equation and solve. All right, so when I set it up, I'm setting up y minus 3 is equal to negative 2 times x minus 1. All right, I'm going to distribute that negative 2, take the 3 over to the other side, and I get y is going to be equal to negative 2x plus 5. And that's going to be my equation to the line. It's going to touch that point at exactly one thing. And if you notice here, I'm starting at 1, 3, and I'm going down 2 over 1, and I'm looking here in that almost line. I mean, that's pretty close of what I have here, going down 2 units if we look here. All right, our slope is negative 2, so we're going down 1 and down 2 to this line here, and then we're going over 1, which is right approximately about right there over top. And that gives us our line. That's what we're looking at. All right, that's our slope of our tangent line. So our guesstimate there of negative 2 seems to be pretty accurate of what we actually have. So based on that, that's what we're looking at. That's going to be our graph. All right, let's move on. All right, so we're looking, the slope of a tangent line and secant line have units that depend on our x and y values, all right? Just like we have up top, remember, these are dependent on your y's, just like we wrote before. This is y2 minus y1 over like an x2 minus x1. All right, these are our y units, these are our x units, all right, our vertical units and our horizontal units. So what we're going to do is we're going to take a look at an example here. So let's give this example. For the given s of t, and we're going to call this function s of t is equal to 3t squared, and this is the graph of it. We're going to say that t is in seconds, all right, and s is in feet. So what we get here is we're going to have a tangent line that will consist of feet per second, feet over seconds. All right. Well, what is that really? What is feet per second? That's some kind of movement, and we normally look at it as being velocity. All right. So when we have things in such as, and we call the standard position S of t is normally how we'll denote that first function, but we can get things in terms of feet per second, which is going to be a velocity term. So we're going to look at certain things with velocity here. And what we want to talk about is we have two different kinds of velocities. We've talked today, earlier today, we talked about secant lines. All right. What was a secant line? Well, that was the average. All right. That was the average. Notice that the average velocity is the secant line. From if we have a graph, and let's just assume that we have a graph here. All right. If we have a graph, all right, and we want to know what happens between, this is the graph here. We want to know what happens between this point and this point. We draw a line between those 2 points and we find the average of that line because it's going like that's our average. That's our secant line. That's what we've talked about earlier. That is our average velocity. Think about it. You can think about it as if you're going to Cleveland and it's 100 miles and you travel, certain times, how fast does it take you? What's your average speed? Does that mean over the whole entire time that you went to Cleveland, you were traveling at 65 miles per hour or 60 miles per hour? No, that might have just been your average. You could have went faster. You probably were going slower. All right. So what we're also looking at then is instantaneous velocity at a certain point. At a certain point on that graph, that is our tangent line. So if we refer back to this little picture here, at this point at 1, 3, our velocity is the instantaneous. That's at that point. Our slope, remember, if we're talking about a secant line, we want to know what happens between this point and this point. That's our average velocity. But our tangent line refers to the instantaneous velocity. All right, at that moment, how fast were you going? All right, so if we're talking about, again, driving up to Lake Cleveland, and you want to know 3 minutes and 10 seconds into the trip how fast you were going, that's going to be different than your average velocity. Think about it. When you accelerate, you're not starting instantaneously at 60 miles per hour. So it might be a little different. All right, so let's take a look at this. We're going to talk about this equation. It says find the height of the rock falling in feet. By given y is equal to 256 minus 32t squared. And remember, t is in seconds. All right, let's find the average velocity. So let's go through this. So our average velocity, we're plugging our numbers in. Remember here, this is just our point. So let's plug in our over this time. These are intervals. So both of these are x values. We'll call this x1 and we'll call this x2. So you need to plug those into your equations. Plug in the value of 1 into t. Plug in the value of 2 into t and tell me what you get. So if we really set these equations up here, all right, what we're really looking at is if we're really setting up these equations here, we're going to take a look at 256 minus 32, and remember, we're plugging in that 2. We're plugging in that 2. That's our x2. So we're plugging in that 2 into our equation. Remember, our equation is just right up here. So we're plugging in that 2 into this equation, and we're solving. All right, then we're plugging in our 1 into this equation, and then we're solving. All right, and when we do that, we get 52 minus 32 times 2 squared minus 52 minus 32 times 1 squared. And on our bottom, it's just our interval. It's from 2 to 1, so it's 2 minus 1. And we get an average velocity from 1 second to 2 seconds of 96 feet per second. All right, we get 96 feet per second as our average velocity. All right, that's in the interval of 1 second to 2 seconds. So between 1 and 2 seconds, we're averaging 96 feet per second, and we're going down, so it's negative. All right, remember, we're falling. All right, when we go through this again, the next one, what we're doing is the same idea here. All right, we're taking 1.5 and 1, and we're plugging it into these two. So really, we're looking at 256 minus 32 times 1.5 squared, and then again with the minus the 256, and now we're plugging in again the 1, 32 times 1 squared. And we're still taking our two intervals here, our x values are 1.5, and we're subtracting away 1. All right, and when we do all that, we're actually getting the value of 80 feet per second. All right, and as we continue on, you'll see that what's the next ones? It's 67 feet per second, and we're going to get 32 or 67.2 feet per second and 64.32. Try those, make sure that you get that those times. All right, so notice we're getting closer and closer to what number here? We're getting closer and closer to we're staying, our x1 is still at 1 second, but we're getting closer and closer to this second set of numbers as being 1. Notice we're going from 2 to 1.5. We're getting closer to 1. Going to 1.1, we're getting closer to 1. We're going to 0.01. So what would our guess be at what the instantaneous velocity is at 1? We keep going down. What would it be as we get closer and closer to that 1? When we get closer, we can't remember. We can't plug in 1, 1 because that gives us nothing on the bottom, gives us 0, and we can't have an undefined. So we're making an educated guess of how close we're going to get. Notice we're getting from 80 to 67 to 64, and we're getting really close. I mean, that's a close estimate to there. So if we're going to take an estimate, our instantaneous velocity, we'll take a guess at about 64 feet per second. And that's what our instantaneous velocity would be using a secant line as you get closer and closer to that point. All right, that's what we're basically looking at. We're taking a look at taking a secant line, all right, and getting closer and closer and closer to that one point. And that's what we're talking about all the way through this first with a tangent line, because that's what it is. Remember, a tangent line is just hits that graph at 1 point and 1 point only. So we're taking something that we know with a secant line, all right, and we're going from here, this line right here, and we're moving this little one up. And now we're going to here, and now we're going to here, and we're trying to get as close as we can. All right, so as we move this up, if we take a look, we'll do this right here. We'll go, here's our first secant line, all right? And what I'm going to do is I'm going to move that dot up a little bit more. Maybe we're going from there to, if I can move it to here, all right? So we're getting that secant line closer, all right? And notice that what's happening to this black line as well. If I go up to here, all right, let's write that in red so we can see it. If I go to maybe right here, what's happening to that secant line in between that 1 point? It's getting closer and closer to that tangent line. Notice how it's becoming more of that same slope. See how the slope is much different from here to here? And then we start getting a lot closer, and then we start getting a lot closer. So what we're trying to do with this secant line is we're trying to get close enough to give us a good estimate of what like that tangent line slope would be. All right, we're going to talk again about this. I'm going to review tangent lines and velocity for tomorrow. We'll probably start the next section and start actually into limits and talk and discuss what limits are. You will probably have homework tomorrow, not during class, but tomorrow night.